I'm founder and CEO of Sourceful. I'm not going to talk too much about Sourceful today. My main theme for today is going to educate you a little bit about DePIN and what I believe is the big next narrative in the blockchain and crypto narrative. That's what I truly believe. Obviously, I'm very biased and I'm open for a discussion about it later, but let's see if you can follow along. And let's go for the definition. I'm an academic, so that's usually how a presentation starts. You define the area and then you go on. And hopefully you'll be able to find this in some academic literature, which isn't really possible. Well, in some sense, it actually is possible because there are a lot of papers nowadays about DePIN. There is in the blockchain conference, the IEEE blockchain conference, actually they had a DePIN session last year. But it's a very, very new narrative. The word DePIN hasn't been around that long. And there might be someone that could point out a specific date or so, but we're talking about 2 years or so. But the main point with DePINs is that we're talking about the centralized physical infrastructure. That is infrastructure that we are used to, could be roads, wireless networks, and obviously we'll go into that a little bit later, but it could also be the energy system. Could be flight tracking, flight radar. There is actually a DePIN project in that space, but there are loads of them. And essentially, that's what it is, using crypto incentives. This is the definition taken from the EV Freeze Annual State of DePIN report, Mesari report. I think it's a good definition. And if we look at from the same report, it clearly states, and I think revenues driven by utility, not speculation. That's, yeah, and you could laugh about that because it's not true, not totally true. But that's the point. We're talking about utility tokens, and we're talking about that the token itself should be able to have a demand side that puts the price on the token. Obviously, with whatever asset that is tradable, you might get some parts of speculation, but the main part with the DePIN project is not creating this for speculation. Then you have a security token, and we're talking about utility tokens. Obviously, we can be honest here. Yeah, it needs a little bit of speculation. Otherwise, you would probably not have that incentive of joining in early and all that. But the point here is that you're using this incentive for building something in the physical world in a more effective way. That's really the point of it. And there are a lot of reasons. I'm happy to share the presentation later on because I did make some research into this area. So there's a lot of references in each and every slide. But the thing here is that we are able to do things in a more efficient way. And obviously, if we talk about the blockchain that is used, as you so pointed out, that if we're going to build things in a more efficient way, we also need a quite efficient blockchain. And those things are possible now. There is, for instance, one application called Sling. I found out about this app, I think last year at Breakpoint. You're able to send actually money to someone in the US, dollars. It's a fraction of a cent. I'm not even sure if they charge anything for it in under a second. And that's because the blockchain that powers this, Solana, is more efficient than the banking system and cheaper. Oh, that's kind of cool. So if you look at a lot of things that we do in the world today, you just look at the energy sector and the building and the building department and trying to link things together. If we use an open ledger, which is also efficient, it actually makes sense. But I think the most important part here is that unlocks new economic models. I think that the economic models are probably the most important part. Some noteworthy DePIN projects, I mentioned them here because I think they are the helium is often what we use, but what has been the OG, the original DePIN project. Helium builds IoT networks They have a vast networks. They almost had 1 million. I think they were up to 900,000 something. IoT hotspots, actually LoRaWAN gateways all over the world. They had a very effective way of incentivizing people of setting up gateways because you got crypto tokens. It worked. People went crazy. They went the extra mile. You couldn't even find a Raspberry Pi in the electronics store, not only because of helium, but it was absolutely a factor. One project which I think is really interesting, it's quite new, been around for some time, but it's still new, I would say, is Demo. They have an application. If you drive a car that is, I would say, already connected, there are a couple of cars that are more connected than others. If you drive a Tesla, for instance, that's a more connected car than a lot of other cars. But they allow you to share the data from your car, and we're talking about data from your brakes, how the, like whatever is in the car's system, you'll get rewarded for this. And how could you get rewarded for this? Yeah, they are able to make a business out of this data, because if they have 100,000 Toyotas and they take this data from cars actually on the road, yeah, Toyota might be interested in actually getting hold of that data because they don't know about it. The cars aren't connected. They have a small device called Macaron, which is also built on the Helium network. It utilizes that one. $100 or so, and you can connect your older car even to this network. So I myself earn about 15 euros a week just by having an app. I mean, how cool isn't that? And these things are what I believe is what's driving the DePIN sector, why it makes it so efficient. HiveMapper is about mapping roads. You put a camera, like a dash cam, and you're able to actually map roads in a more efficient way. This is the super team, the map of the Solana map of the DePIN projects on Solana. I would say that talking about blockchains, obviously you might all be like Solana biased here, but there are chains that are like the chain of DePIN. We have Peak, we have IoTeX and such, but Solana, I believe, is perhaps the strongest chain in this sector still. We'll see how it goes. But you have a lot of different projects, and if you look at it, you see Helium up there, and you actually can see Sourceful down in the sensor. I believe that the category is wrong, but there isn't an energy sector, not just yet. We'll see soon. And to speak about a little bit of background, keep time for me, because this is a map of where I live. Obviously, it's not a normal map. It's a map of the Helium Explorer. This map was taken 2021, so I put the date here. And this is a tweet from the COO of Nova Labs, which was formerly Helium. And why I'm showing this is that the network that has been built in Kalmar, in Sweden, we're a city of 60,000 people. It was not built by Helium. It was built by me and a couple of other guys. We climbed ladders, we climbed roofs, we did the extra mile, we even did the mapping. So this is the mapping of network. These aren't hotspots that you see. We have been driving around and mapping the network for free. Well, actually not for free. We made some payback, significant payback. And just to compare, because I think this is the interesting part, there are other LoRaWAN networks out there. Actility has been around for quite some time. We can see we have the Things network. And those of you that are not into IoT, they're like Verizon, T-Mobile, whatever. But Actility is a French company, very business-to-business focused. Actually, that red line, I put it there myself. I don't have the actual data. But I know that they are writing on their website that they have 35,000 gateways. So that red line should probably be moved down a bit, actually quite significant. But Helium, and this, you see it ends at 2022. I didn't have time to take a new version, but it will be an S-curve. It actually will sort of flatten itself out. But what they did was to do this in a totally different way. They built the world's largest IT network, and by just incentivizing people with tokens. They didn't start out as a DePIN project. They started out as a, let's build a wireless gateway, put it in people's home. When they put a tokenomics model on top of this, then it took off. And this is the cool part. This is, by the way, me. I'm actually in quite high up. I think it's 50 meters, and that in yards is, well, let's say 50 yards. Yeah, but it's in a high tower. This is what people do. And that singular gateway, because this was early 2021, you have like to know the facts. Why would even someone like me bother climbing up a ladder and doing all this? I think it was 200, 300 pounds, about that, per day in income in the early beginning. Speculation, you might say. Yeah, it was speculation, obviously. But anyhow, this drives the network to like an exponential growth. So let's go on to another real-world challenge. And I would say that one that is quite important. We could argue that a lot of things are important. It's super important with wireless networks, with mobile, and that we can find a lot of things that are super important for us. But what I think and believe is one of the most concerning parts is that we have a need for renewable energy. We need to change the way we're living. And that's one of the main reasons that I'm in crypto at the moment. It's actually to use these incentives which I'm talking about, what we saw with helium, using those for something that actually make a change in the world. And then we're talking about physical networks. So we're, like what we're doing is probably one of the hardest projects, but we're trying to do it anyway. So this is first principle engineering. So I'm just going to skip that slide and go on. This is the same problem all over the world. It's not a single country problem. We have the same kind of physical laws all over the world. And this was from Faith Biro. He's the director of the IEA. He actually, this is a quotation from a LinkedIn post he had a couple of years ago. I think it was 2022. And this is what he said. The king of global electricity markets. That's the PV, the photovoltaic solar panel. Why is this? We see actually a quite exponential growth in this area. And this is data directly from the IEA Energy Data website. You can go in and check for yourself. What we see in this, what I pointed out here, is the PV distributed systems. So we're not talking about big solar farms, but rather like rooftop solar. We see them in big numbers, and there is an acceleration going on. And why is this? Solar is actually the cheapest source of power today, if we talk about kilowatt hours. It's the cheapest source. So we like, yeah, where do you put your money if you're going to build more renewable energy? Is it wind? Yeah, perhaps, but solar is cheaper. Obviously, it might not all be sunny all the time. So, I mean, we have physical laws, so I'm not going to say anything about that. But in the next couple of years, at least the IEA thinks that we're going to quadruple, like 4 times more distributed solar, and we're talking about world statistics, so we might see different things in different countries. But what I'm pointing out here is that we see actually an accelerated expansion of this. And this is not all good, because you might say that just installing solar panels, that's really good. It's perfect because we are producing renewable energy. Yeah, absolutely. But you can't have more than 25%, and you're actually nodding here, I think you're into the area. But you can't put too much solar in a system. It's actually not possible. Well, it is possible, but you will get problems. And the problems here, and this is taken from the What to Look For in 2024 Wood Mackenzie report about the PV outlook in Europe. And I think it says it quite, like, we will see an increasing challenge in the system if we increase the number of renewables. And especially solar in this case is what we see is being built all the time. And you can find rather good statistics and data from the California grid system. So that's why I use that. And also they have a lot of solar. Actually, they do have a lot of renewables in California in the US. We have the same thing in Sweden, but not to this extent. But what we see here is that we have negative prices in California midday. That's not good. You're actually putting taxpayers' money in the pockets of those that have solar because they get subsidies. But still, they are making like the life hard for the grid owners and all other electricity that needs to be there when there is a cloud coming over the solar panels. So we're creating a system that is not good at all. And I mean, there isn't just one solution to this. I'm not going to say that, oh, buy like this device or do that and that. It's many things that needs to collaborate together. But it's the collaboration part that is the important one. And you can see now that there is curtailed solar in the very top. So the sort of yellowish, the more lightish yellowish part, that's actually when you have solar power, but you're not using it to the full extent. You're actually using it less than it could be. You're actually talking to inverter and saying that you produce less. There is more graphs, but I mean, if you just look at this, this is usually how it looks in the system. And when I said first principles engineering before, there is always an equal amount of power that is produced that is consumed. Could not be anything else. That simple. So you might say that, oh, I'm overproducing a little bit. It doesn't work like that. It's always the same. That's where you have the balance in the grid. So you have 50 hertz or 60 hertz, depending on what. Directly when that sort of drift off, you're actually trying to push more power into the grid than what's actually consumed. But there is always a balance. So when you flip on a switch for your TV or whatever, something else in the systems produces a little bit, tiny bit more power in that instant moment. Obviously, there is some latency in the system and such, but you have this rolling mass and so. But yeah, we do have a first engineering principle problem. And yeah, you might say that oh, solar is so cheap, then why shouldn't the electricity price drop? And I think that we have seen this in many countries, and the same in Sweden, and there is a lot of data from the US as well, that we see that the delivery costs are rising. So, and also when we're creating these kind of systems that aren't working correctly, it's not effective for anyone in the system. It's not good for anyone. And this is just a graph from the US market, and looking at the power delivery costs are rising and the energy costs are actually shrinking. So we might end up with a situation, and there is a lot of publications in this area, that if the power delivery cost gets too high, people might not want to be on the grid. They might want to actually live off grid. And we see a lot of movement in this area. That's actually not good for the system. We want things to be connected. We actually all are better off if we do have a common grid, not everyone on their own. So this is a problem that needs to be solvable. I just put some examples that they're solar, yeah, it's good, but yeah, it does have real problems. So I'm not going to say that this is the solution that will fix everything. So in Texas, they do have solar. And if something goes wrong with, it could actually be a cloud, if there is a solar eclipse, you might have a problem. And the way forward for a lot of, let's say the solutions is you need to put a control part of this on top of this. So not every solar plant on their own. They should obviously be connected and talk to each other. They are already connected, you might say, because every solar plant that a homeowner has an application, more or less everyone that has a recent installation and not 20 years ago. But it's an application that shows the data. It's connected to a server in China or whatever. It doesn't speak to the utility company. The utility company doesn't actually know a single thing what happens inside your utility meter at your end. So this is a problem, and we need to be able to close that gap. I'm going to skip these slides very very, just to show that I've done my research. But there is, I found actually, for those of you that are academics in here, there is an excellent article that actually dives really deep down into this problem. And if you look at this, one of the, I would say, most effective solutions for this is creating the decentralized control and standards on top of the energy production. So I'm going to skip this very fast and say that, yeah, we need a decentralized control. That's more or less what that I want to tell. We could do this in different ways. And now we're on to the part where you just accept that, oh, okay, we have a problem, it wasn't all that good, yeah, we need to control them, we need to do it in a decentralized way. Okay, couldn't we use it in a centralized way? Yeah, we could. You could actually make a business model out of controlling solar plants, no problem. I could start my company, I could speak with customers, oh, here you have a gateway or connect your device. And then I call the utility company and tell them, no, I have a solution. It's a win-win solution. And then we'll trade some money and back and forth. And absolutely, it's a viable business idea. Utility companies are already doing it. There are several companies in Sweden that mainly are working with batteries, it's like home batteries, because that's when you have the big power. Like, and there is markets for this. They're called demand and response markets. The thing here is that if you want to reach every single device, if you want to reach the homeowners, it needs to be simple. Well, obviously, if they can pay it, they can pay for them themselves. If they also can go the extra mile of like doing something like, okay, it doesn't work, like instead of picking up the phone, they onboard a Discord server and like help out each other. You see, it's a lot of money to save here on actually the doing part. That's what happened with the Helium project and all other DePIN projects. And how do you scale a business like that? Exactly what I said, global from day one. It's a global problem. It's not linked to the UK or Sweden, or like all electricity markets are different, but it's a global problem. It's a global challenge. How do you scale from global? Yeah, it's possible, but I mean, it will be harder. It will be much harder. But with the DePIN approach, it's actually very straightforward. You just do it. People just onboard their gateways. We are already proving that this works, by the way. So, but that's the power of a DePIN project. And I'm going to look at some projects that are doing more or less the same thing that we're doing at Sourceful. But as far as I know, there are many more energy-related blockchain project. You have like energy web, etc., etc. But now we're talking about projects that are also utilizing hardware and building virtual power plant. And as far as I know, Rowan Energy, which is actually a Scottish company, I think I don't know exact which city, but they are up here in the north. They are doing more or less the same thing. No one is doing the same thing, by the way. Everyone is different. They have their own blockchain, actually closed source, and they are running their own blockchain. I wouldn't, yeah, you can ask me later what I think about it, but then, and then we have ArcGreen. It's an Asia-based company. They are also into solar and doing a little bit of different thing, more focus on mining green Bitcoin, but they are still doing the same thing. And then we are, yeah, we all have gateways. We all do the same thing. And we have a gateway. We're doing this as like building the world's largest VPP. And I'm going to skip this through very fast because I think my time is sort of up now. Q&A, yeah. This is obviously a pre-recorded video of me just scrolling through how the Explorer looks, because I think the data part is so important. And what we have seen is that when you do have your application running on your, like you have your homeowner plant, obviously I have solar at my home, and we have a lot of homeowners that we're working with. And these applications are actually really crappy. It's like when Volvo tries to make their smart app for their car, and well, I say, take Volvo as an example because I'm Swedish and no one will like blame me for being, but it's crappy. They're making cars, they're not like software engineers, they're not good at these kind of things. We see the same things with with inverters. They're electronics companies that are making inverters. They are not good at these things. So just making the application faster and better is actually creating a value. And no one has, as far as my knowledge, created a map of renewable PV production on a world scale. That's what we're trying to do. You could just imagine like the kind of businesses you could build on top of this. I mean, we obviously can imagine a lot of things, but what I'm coming here is that there is endless opportunities of building things when you start to connect things. But the part here is that you start connecting them without needing to have closed a deal in the other end on the demand side. The same thing with helium. They didn't have a strong influx of fiat money coming in buying IoT services. They still don't. They could still build a network. People were going the extra mile. I mean, you all know that just creating a token and giving out the token doesn't cost actually almost nothing. So, but it still works, and that's the crazy part. So that's more or less all from me. If you want to connect me on Telegram, which I understand is the main form of communication in the world of crypto, it's I was a bit surprised like 6 months ago when I was a breakpoint, like there's only Telegram, so I'm sort of switching over to that as well. Yeah, and but that's us, and that's Qt, by the way, because we saw that other projects all have some kind of meme-ish animal, cats or whatever. So we thought that like no one has picked a hamster yet, so we'll pick that one. But it's just for fun. So we try to be a little bit more serious than that, but yeah, that's us.